So I alluded to the advanced API. This is one of the more complicated parts of this, and it took a non-trivial amount of time to figure out exactly what the correct semantics are for this. But the problem is that you have a robot, Mr. Smiley Face, moving in time, and he's going to drive past objects in the world. So as he drives past object 1 at time 0.25, object 2 at time 0.5, now at time 1 he wants to keep driving, and he wants to be able to avoid the things that he saw in the past. So to avoid these, he has to know where those objects are in relation to where he currently is. So he saw it, so one piece of data came in at one time equals 0.25, 0.5, and now we're at 1. And to compute where the data is, you have to be able to make an assumption about where the object is that is not moving. So for navigation, we make the assumption that the object is not moving in the world frame. So that as you're driving, you see a chair, you're going to assume that chair is fixed. But obviously this is not a valid assumption. If the chair is tied to your side or is trailing behind you, things are going to break. You need to be careful about how you choose it. And what we call this is the fixed frame. And so basically, as the robot's driving, the object will be transformed from its current position into the fixed frame. It'll be jumped in time to the current time and then transformed into the frame that you want. So this is, well, I pulled this from the turtle tutorials, but sort of a graphic representation. Turtle 1 observes an object. It's transformed into the world frame. Both turtles are driving around in time, and you don't know, the time is offset. So you transform the object into the fixed frame. So you compute this transform. This is assumed to be 0. And then you compute the net transform from your fixed frame into the turtle frame, second turtle frame. So here's a quick example. You observe some ball in the ball frame, and you want to get it into the target frame at time newer than when the ball was observed. So you simply ask it for, give me the transform from the frame the ball was observed in at the time the ball was observed. Give it to me in the target frame at the target time, and assume it did not move in the fixed frame. And it'll return you the result, or throw an exception if that's an invalid query. A neat example of the power of this query is that if you actually want to know how far the robot moved between time 1 and time 2, you can actually use this query. So you just say, ask the robot frame, time 1. So it'll take the robot frame, transform it into your fixed frame, which is, say, the map. Then it'll jump it in time, assuming it did not move in the map. The previous observation of the robot did not move in the map. And then it'll tell you where that is in your robot frame now. So it'll tell you that you were X meters behind where you are if you were driving forward.